Welcome to this session on IoT, or simplifying how we can design IoT solutions. My name is Jean-Pierre LeGoaller, or JP for short. I'm a senior manager of solutions architecture at Amazon, responsible for Central and Eastern Europe. And I came today with my fellow solutions architect, Vladimir, in the first row. So if you have any questions about Amazon, we'll both answer them after the break or during the break. So today we're going to discuss Internet of Things and how we can simplify Internet of Things solution. So we will start by general introduction to IoT for those of you that may not be super familiar with it, and then we'll try to explain how you can do IoT in the cloud, and finally we'll have a little demo to see how it works. So. Let's talk about product interface, right? So let's say you want to lose weight and you use an online program, right? So you go to your scale every morning and you weigh yourself, and then you go back to the computer and you enter your weight, for example, right? So that's a mediated interface. That's something that's not the direct interface, right? And then we had simulated interfaces with, the smartphones and tablets, where you can have a nicer interface, more realistic for some products. It's still a virtual interface. And now we have, with these IoT products, we have a direct interface. So if you want to, if you have a smart scale like this one, you just tap on it, and that's all you have to do. You don't have to go back to the computer and enter it. It just sends it to an IoT backend service where it will be stored, and then you can use some tools to report on it. So the product becomes the interface. You don't need a separate interface. So that's kind of the IoT in a nutshell. So of course, then you can enrich that via additional apps that gives you more insight into your data and reports and track your progress. And maybe you get emails to congratulate you on losing a pound or two. But the product itself is self-sufficient. And we're getting to a product that more and more natural in the way they communicate with us. So to me, today I brought with me Alexa. If you've never met her, that's her here on the table. So we're trying with Internet of Things devices like Alexa to have a more natural communication. So when the organizers asked me to come here, the first thing I said is, Alexa, turn on. Here we go. Sorry. Somehow it turned off after a while. That's the beauty of demos. Alexa, can you help me out, Vladimir? It worked a second ago.
I can't find the answer to the question I heard.
Okay, that's good. Alexa, where is Budapest? Wrong country.
Budapest is the capital of Hungary.
So that's the wrong country. Alexa, where is Bucharest?
Bucharest is the capital of Romania.
Alexa, where is Romania? Alexa, where is Romania?
Romania is a UN-recognized country in Eastern Europe. It shares a border with Hungary, Ukraine, Serbia, and Moldova.
Great. So, and one thing actually I know where Bucharest was, I know where Romania was. What I didn't know is I was on the phone with one of my colleagues, and he said, before the conference, we need to have a call with the customer. What time is it? Do you know the time difference with Romania? I was like, no, I don't know. So I said, actually, I was on my desk next to Alexa. I said, Alexa, what time is it in Romania?
The time in Romania is 9:51 a.m. on Friday.
So I knew it was one day ahead of Luxembourg, where I was sitting. So it's a nice little device where you can interact really naturally. My kids love it because they can ask tons of questions. You can say, Alexa, tell me a joke.
How does Jack Frost get to work? By icicle.
Right? So they're kind of geeky jokes, but sometimes I have to explain. But yeah, so it's a fun device. Or my kids will say, Alexa, I like you.
Thanks. I like you too.
So it's fun, and it's an interface. When kids like the interface, it means you have a good interface. It's very natural, and they can use it. So anyway. So the point is, it's a natural way to interact with Internet of Things. We won't talk about Alexa the whole session. And it's expandable, right? So the nice thing about Internet of Things is to make products expandable, to have more and more functionality. Just like you can maybe add apps to your smartphone or to your tablet. In an IoT device, you don't have to do that. The apps are added in the cloud for you. You don't even have to install anything. It just becomes more feature-rich every day. For example, Google announced last week that you can now set the Nest thermostat with Alexa. So you can say, Alexa, I'm cold, turn it up. So it gets more and more features. You can say, Alexa, lock the door, because some smart locks vendors have integrated with Alexa. You can say, Alexa, turn on the light, turn off the light. So it becomes kind of fun. And it becomes richer every day. And so we have this SDK, the Alexa Skill Kit, that you can use to create new applications for Alexa, new skills, we call them. And I encourage you to try it. And by the way, if you write a new skill before the end of March, you get a free T-shirt from Amazon. So why IoT? So the first thing we just talked about with Alexa is smart products get better with time. So let's look at an example of the Tesla cars, right? So until recently, if you wanted a new feature in your car, you had to buy the new model, right? The new feature comes with the 2015 model or 2016 model. That's a pretty high bar, to get a new feature. Or sometimes you could get a new firmware update by going to the shop. So now we have this car maker that's totally changing the way updates are done and uploading major features to your car over Wi-Fi while it's in your garage, like autonomous driving, like being able to call your car so that will come to you when you call it. So that's the way the product, the thing, which is the car in that case, gets smarter, on a if not every day, on a weekly basis. Another good example is Sonos. They've sold speakers for the same speaker for about 10 years. They just upgraded it last year to a new version. But for 10 years, they really had the same one, and they were adding features all the time. So you buy a product, and unlike the old model of maybe the not-so-smart products, the smart products, they get better over time. And that's a really nice thing to have, where you feel like you get something new. It just comes to you for free and automatically. And you can see that as they mature, they get more and more features, kind of like AWS in a way. So the other thing is smart products, from a vendor point of view, allow for data collection, right? So you get more data, you get more knowledge. With more knowledge, you can make better decisions. For example, going back to the case of Sonos, because they run on Amazon, that's why I'm mentioning them, they found out that people don't really download songs first and then play them on Sonos. They just stream them, right? Huge majority, 92%. So that gives them an insight on how their product is used. That's always valuable insight for the device maker. So you can see what features work, what features don't work, and then you can focus on improving the features that do work. The other thing is smart products enable agility, right? So as a developer, you're probably familiar with DevOps. I know you are. So you get quick feedback from your users, and if you're agile, and if you follow a lean development method by which you will experiment with new features, measure the results. Are people using these features or not? Are they struggling? Sorry, I went up. You can then iterate, right? You can make the feature better, and you can go really quickly with this agile/lean methodology. So it's a great thing also from a developer point of view. And the other thing is, maybe most importantly, is they make possible IoT products, smart products, offerings that were not possible before. So see an example of Philips, where they're developing this solution on AWS, where you will have, if you want, you can wear a device on yourself that will measure your vital signs, such as your heart rate, your blood pressure, and so on, right? Level of oxygen in the blood, etc. And they will be able to correlate that with all the former medical exams that you've done. So you will have you already have smart MRI machines, for example, that will upload your data into a central file that is all the data around you. So when you go to the hospital, they can have access to all your files, and they don't have to ask you, are you allergic to something? What kind of conditions do you have? They should know when you arrive already. And better than that, what the CEO of the Philips organization was saying is that they're hoping that in the future they will be able to correlate your vital signs with your medical history and be able to know your condition before you know it. For example, they might know you have a heart attack before you know it yourself. So they will be able to send, possibly care, to you if you have a GPS sensor and tell you you're having a heart attack. We need to bring you to the hospital. So this is really something that is not possible, today, and that's really exciting. And of course, then you have an app that you can use to monitor your progress and your health. In a different area, BMW spoke at our last user conference in Las Vegas, and they were explaining how they use AWS to use the car as a sensor, which they call car as a sensor. In this case, for this application, if you use GPS frequently, you've probably noticed that sometimes the GPS tells you you're flying over a field, right? Because it's a new road, the GPS doesn't know it. So they assume you're just going through a field. So the sensor here will correlate all this data, and if he sees enough people going through the same field, it's probably because it's not a field, it's probably a road there. So he will add the road to the map, making it a better GPS that gets smarter automatically. If the sensors notice that you're sliding, you're skidding on the road, and it's cold, probably there's an ice patch there, so it will be able to warn the other cars that are coming to the same patch that, watch out, there's a spot of ice right there. It will be able to tell you exactly where. So again, an example of an offering that just is not possible without IoT. So let's look at it from, so I will divide IoT here in two areas, consumer and industrial. So let's start with consumer. So you see some products here that have been around for many, many years. We have a tennis racket, we have a lock, we have a fork, we have a pill dispenser, teddy bear, and a water sprinkler, right? So how many connected devices do you see that will exist based on, and have the same functionality or be the same object? So do you see 0 IoT products here potential, or 6, or somewhere in the middle? Well, let's see. So I heard some 6. Let's see. Let's look at the tennis racket. So you have now a connected racket that's going to tell you how long you played, how many backhands and forehands, how hard you hit the ball, both on your serve, your backhand, your forehand, whether you center the ball, and it will tell you where you hit the ball when you do a backhand, a forehand, or a serve, how fast you hit the ball. Does your power decrease over time, which means maybe you need to train harder your endurance? So all this stuff that, it doesn't only make sense if you're a tennis player and you love tennis, but it's kind of a cool little feature from a product that you think will be a smart product. So that works. Locks. You have smart locks now that are available, so you can unlock the door of your house via a smartphone, which is convenient. It's in a way more secure than a real key, because if you lose the key, anybody can use it to open the door. If you lose the phone, you still have a PIN code to enter, so you have a protected key. If you have guests at your house for a week, you can make a digital key that will expire after a week. So it's this kind of little improvements that make life better. It's not life-changing, but it makes life better. The fork. I eat way too fast. So this fork will start vibrating if it detects you eating too fast. So you calm down and you eat more slowly and you speak more slowly, like I should do. I probably need a smart microphone to tell me when I'm speaking too fast also. And then, of course, there's an app. You can go and check, if you're doing progress and how many bites you took, etc. So it's kind of fun. A pill dispenser, that's more serious, right? A lot of people forget to take their medicine, and if you have a cold, it's okay, but if you have a serious condition, it's maybe not okay, like forgetting to take your antibiotics. My grandma had Alzheimer's, and she was forgetting her medicine all the time, or she was taking 10 times her medicine because she forgot she took it 5 minutes ago. So now you have this company where they made this smart pill dispenser. So what happens is you configure it first to say, I need to take that pill at 8 a.m. and 3 times a day or twice a day at these times. And when it's time to take your pill, it will start to glow. So the cap of this device will start to glow when it's time. If the pill is in the fridge, because it needs to be refrigerated, you have also a lamp that you plug in outside of the fridge, and that will glow when it's time. If you forget, it will glow more. If you still forget, it will page you or send you an email. It can even, if you're an old person, right, it can email your family saying, hey, your grandma forgot to take her medicine. So they did some studies on this, and the adherence rates, or how often people take the medication, is way higher. So people don't forget, and in some cases it can be life-saving. So again, something that was not possible without IoT. Another teddy bear, a connected teddy bear. Yes, it exists. And first I was wondering why, but it's actually very smart. Let's say you leave your little child in daycare, for the first time, right? Or your little child is in the hospital and misses his family. You can send text messages to the teddy bear, and when the child touches the teddy bear, the teddy bear will read the messages. So you can say, I love you, I miss you, and it's kind of nice. The kid gets some messages from his parents or his family. Another connected teddy bear is for babies. In hospitals or at home, but mostly in hospitals, it's difficult to take their vital signs. They don't really cooperate, right? So here, by just touching the paw of the teddy bear, it will measure the heart rate, the temperature, the level of oxygen in the blood. And if the kid has fever, the heart will become red. So the doctor or the parents can say right away, oh, my kid is having fever. So a nice way to work with babies. Another one, maybe less life-changing, the water sprinkler. They tend to be pretty unsmart, right? So in Luxembourg, we don't need them because it rains all the time. But I used to live in California, where you do need them, or in Utah, where you do need them because it gets very dry. The bummer is someday it rains and you forget to turn it off, and you're just wasting water. And as you know, might have heard of, they have severe droughts in California, so wasting water in a yard is really not super smart. So this you can configure these sprinklers via an app to water your lawn at certain times, depending on the type of the grass, or is it a flower bed, or is that trees, is it sloped, or is it flat? And also it will connect to your local weather station, so that it will skip the watering when it's raining. So nice way to save water in California, and this company runs on AWS using AWS IoT. So all of them were smart products. So if I heard some 6 as an answer, that was the correct answer. I'll give you one more, a bonus one. So Whirlpool announced a new line of washing machines that will automatically order more detergent when they're running out, and they will order it, of course, from Amazon. Though that's only in the US today. But that's not life-changing, but it's convenient, right? You don't run out. It just reorders for you, get it in the mail. Soon you will get it by drone, but not yet. And so if you don't want to buy a new washing machine, we also have these little IoT buttons we call Amazon Dash. You just press it, and it will order the detergent for you. So we have a little dash button. So that's a way to hack your washing machine. You don't need to buy a new one. You can make it an IoT just by sticking the little button on it. And by the way, you have to confirm on your phone to avoid that your little child orders like 100 orders of detergent. And it's just the tip of the iceberg, right? I'm convinced we're going to see more and more. This is just the beginning. It's still a bit, not super widespread, but this is just the beginning because these products are fun to deal with. They get better over time. I have only 10 minutes left. Okay, I'm barely started. So yeah, it's just the beginning. And we can see we will have more and more connected objects, billions, right? And we don't know how many billions, all the analysts differ on the number of billions. We know it's just going to be a lot. And then you have the industrial Internet of Things, where you have kind of the same requirements, except you need typically more security. You need very durable offerings, and for example, GE, they make these jet engines, they make these, wind turbines, etc. These things need to last for like 30 or 50 years. So having a smart product makes a lot of sense because you want to be able to update and make your product better over the life of the 50 years. And at that point, you need a reliable backend to ingest all this data, and that's where cloud solutions can come in. So we have customers doing IoT, developing as we speak, new IoT solutions on AWS in very different verticals. These are a few examples. So let's talk now a bit about the cloud. So why the cloud with IoT? Well, you need, when you get an IoT solution like, let's say, sensors in a jet engine from GE, they're going to generate 500 gigabytes of data per flight, right? So if you multiply that by the number of flights happening right now, or in a day, that's a lot of data. And then if you want to analyze it, you might need a lot of computing power. So where do you find pretty much unlimited storage and unlimited computing power in the cloud? So that's why cloud is kind of a natural fit for IoT as a backend, right? So the idea now is to connect your sensors to the cloud. So the first thing is you want to be able to easily connect and to be able to manage your devices from the cloud without having to connect to every single device. And then once you get the data in the cloud, you want to you want to have a way to ingest this data reliably. You want to be able to analyze it. You want maybe to use machine learning to make smart predictions to be able to interpret the data you're getting, and that's things you get in the cloud. So I'm kind of flying through my slides now because I'm running a bit late. Our customers were telling us, we can do it today with AWS, but it's kind of a do-it-yourself thing. We would prefer for you to do it and take care of scalability, security, manageability, availability, and so on. So we decided to try to make IoT a bit more simple. So we have a lot of services that customers use to develop IoT solutions before we had an IoT solution using a mobile portfolio. I'm going to skip a bit on this to catch up some time. But what we try to do is have a solution that connects sensors to backend storing and processing, and then can go back to update and talk to the sensors. So that's AWS IoT. So quickly, this is the architecture of the product, and I'm going to kind of walk you through what it does because it's maybe a bit intimidating like this. So first, there's authentication, right? It's very important to have secure and secure IoT, especially for industrial IoT or for healthcare IoT, for example. So you're going to be allowed to authenticate, to communicate via HTTPS, via MQTT with certificate and private key authentication, or via secure WebSockets. You also want to keep track of all your devices and what revision they add in terms of hardware and firmware and lots of per device information you want to keep in a database, if you will. Then you have the device gateway, which is the center of the offering. It's the gateway to which the devices will connect over MQTT or over HTTP or over WebSocket. And it works in a pub-sub model, publish-subscribe, so your devices will publish information to the gateway and subscribe to topics that the gateway will send them. So why MQTT quickly and not HTTPS? It's an old protocol, it's nothing new, but it's very efficient versus HTTP. It's much more lightweight, it's faster, it consumes a lot less of battery, which makes sense for small connected objects that run on batteries. So it's an old protocol that has found a new life with IoT. We also added a rules engine. So you get all this data flowing through, potentially a lot of data. So we have a rules engine where you're going to define simple rules that look like SQL rules like this one. And you're going to be able to say for all the messages that I'm getting from my devices that match this rule, take an action. So let's look at actions. You can directly you could, for example, store everything into S3. For example, Amazon Simple Storage Service, or send all of my messages to Kinesis ingestion storage. Or if I get an abnormal value, I exceed some kind of threshold, send a notification through a simple notification service, or run some computing on that number because it's abnormal and I need to do something a bit more complicated than just sending a notification through AWS Lambda. And then from these services, you can push that further on in the AWS services to other storage services and machine learning, for example. And finally, using Lambda or notification, you can actually communicate back to on-premises applications or applications running somewhere else. An example here is to send alerts if you get an abnormal value, like you monitoring the heart rate of people and it gets to a range that is dangerous, you want to raise an alarm so you can act on it. So the rules engine will automatically send that notification to SNS for you. You just configure it once and you're done. If you get a lot of data, like we're talking about jet engines, the MQTT gateway will not store that data, right? So you need to do something with it or if you don't want to lose it. So you could say, send all of my data to Kinesis, which is an ingestion engine, and then from Kinesis will store that data for 24 hours, and you can pick it. You can have your apps or the AWS services pick it up from there and store it reliably for the long term. Another good example is machine learning. If you get a lot of data, sometimes it's very obvious what data needs action. Like a simple threshold has been exceeded, but sometimes you need to correlate different parameters to find out if you need to take action. So you could send all the data to S3 to train your machine learning model, and then for every single message coming in, you could send it to Amazon Machine Learning to get a real-time prediction on whether I need to act on this or I don't. The device shadow is another interesting feature where this stores the states under a JSON format, the state of your connected device. So you don't have to go to the device itself to know its state. You can go there. And not only that, but you can, the device will send its current state, which we call reported states, to the shadow, so you will know what the device said, but you can program against the shadow to change the state of the device. So I will do a simple demo at the end to show you that. And then finally, we have an SDK. So for devices and themselves, we have a C SDK because C is still very popular for devices. We have a JavaScript SDK, and if you're Arduino fans, an Arduino SDK. So that's in a nutshell, AWS IoT. Pricing is always important. So we stay true to our values, which is you only pay for what you use and you pay as you go, and you only pay for the number of messages you send or receive. You can connect 100 devices. If you don't use them, you don't pay anything. So that's kind of the crux, right? It's based on number of messages, so it's pay as you go. Pricing, you can. I'm just mentioning that because I know you're not about to buy it, right? But if you're a developer, you can send and receive 250,000 messages per month for free. So if you're developing a solution, that should be enough to get you started and use IoT for free. So I hope that's a compelling value proposition. So in a nutshell now, we try to make IoT, to take IoT and make it a managed service for our customers, to make it secure, scalable, and highly available, which are the three things you need to have to make an enterprise or a solid solution. We try to make it flexible in the sense that you can see with all these features like the rules engine and the shadow, you can really have a flexible way to interact with your devices. It's easy to integrate with other backend services and even with on-prem services, and it's pay as you go. So now this was only released in December of 2015, so it's pretty new. We're starting to have some companies like Philips develop on it, and the sprinkler system I was showing you earlier is actually already running on it. So how to get started? So you can. If you don't have a device, most of us don't have a ready device like an IoT device, right? So all you need on a device is a private key, a certificate, and the IoT SDK. That's all you need. So your computer can be a device to get started. I will show you a little bit later. Or you can start with some of these kits that are available on Amazon.com, sometimes difficult to ship to Europe. But these manufacturers have done these little boards that are preloaded with the AWS SDK, the IoT SDK, so they're easy to use. So today, I brought with me one of these, which is the Intel Edison. And so it's, so that's a little, and I have just a little light attached to it, right, a little light sensor. I also have a little growth kits, you can, if you like to play with devices, you have this little board that you can plug on top of it, and then you can plug in a bunch of sensors like temperature, humidity, motion sensors, etc. So that's super easy to play with if you're not strong at electronics like me. I mean, I'm not strong at it. Let's try to do a little demo. So if you haven't, you cannot see, yeah, okay, so that's the board. Let's see, I need to change, let's see. Can we maybe show the console now and the demo will, maybe if we can go back to the screen. Yeah, we go, sorry. So this is the AWS console. Let's go to IoT. That's not what I wanted to do. Yep, okay. I don't know why it's doing this. Sorry? I know, but it's coming back automatically. Yeah, I'm trying to do that. Geez. Okay. Okay. That's not fun. I don't know why it does that, actually. Geez. I don't have even time to interact with it. So let me see what I can do. Well, I won't show you the console because we're running out of time anyway. Actually, I need the console, but let's see. Yeah, I will just open a new window. So let's do that. And of course, it's going to open a new window somewhere else, right? There we go. So sorry, I'm running a bit over time, but we also started late, so please be patient with me. So this is the console. Can you see it well? Yeah, it's a bit maybe too big now. Went a bit overboard on this. It's not getting smaller, so okay. So you can easily here create things. So you could say, yeah, resources. This is my resources. So create a resource. So everything is based around a certificate, right? So you will first, whatever you do, you will first create a certificate, or alternatively, generate your own certificate using OpenSSL or something and then upload it to the console. But the certificate will be mapped to an object, to authenticate that object, and will be mapped to a policy, and that policy will say what this object is allowed to do. For example, subscribe to a given topic or publish to a given topic. So certificate is kind of the cornerstone of the model here. So you create a certificate, then you will just create a thing, say, my new thing, my new toy, and then you can add attribute like, this is just basically tags like firmware, version 0.01, and more, etc. So you can just create your thing. And then finally, you will create a policy. And that policy will be a JSON statement that gives it privileges over AWS resources or IoT topics. Again, ability to post and to publish and subscribe from given topics. And once you've done that, you can attach the certificate to both the thing and the policy, and you're good to go. So here, for example, I created a little light from a little light here. And that's the state of my light. Okay, so now going back to my other, sorry, no, that's not what I wanted to do. So which one is this one? SSH. So this is on the board itself now, which I powered and attached to the Wi-Fi before we started. I have a bit of code here. I just want to show you how that works. It's pretty simple. So that's on the device, on the Edison board, right? So you put your thing name so it can authenticate itself or identify itself with IoT. You would tell it to which IoT region or AWS region you want to connect. In this case, it's in Dublin. You enter a pass to your private key on the device and your certificate. By the way, that's key to have the private key and the certificate on the device, right? Because once the device is out there, you can't access it anymore. You can remotely invalidate certificates, but you cannot remotely add new certificates. So a little tip is to create more than one certificate. just in case something is wrong or you need to invalidate it. But just put more if you're going to have a physical device. Put more than one certificate so you have a backup plan. So here I'm just going to load a few libraries. Johnny 5 is a JavaScript library to interact with my board, and Edison is the library for the board, for Edison board itself. And then I'm going to create a thing, shadow, an object based on my key and my thing name and my region. Then I'm going to initialize my little light here, which is an RGB light, and I'm going to turn it off. And then I'm going to connect to using the AWS SDK to the IoT, to the shadow feature of the IoT. So I'm just going to ask it to connect and say, report my name and say, I just turned myself off, right, which was done just a couple lines earlier, right? And then once I've done that, I'm going to start listening to the delta topic of the shadow to tell me whether there's a delta, a difference between what I am and what IoT wants me to be, right? So I can update myself based on what is in the cloud. So now if I go back to the console, I can I make this a bit smaller here? I can edit I can update the shadow and say I update the desired attribute to on, right? By the way, is this thing running? No, it's not running, so it's not gonna work. Sorry. Let's do this. Let's start. So this is starting. This should be done at boot time, right? I just want to show you that. So when the device starts, it has to start, some kind of way to integrate with, to communicate with Amazon. So we're registering the shadow. There we go. I just reported that I'm off. I turned myself off. I reported to IoT that I'm off. So now I just want to, from the console, I want to update my object. I want to say, no, you're off, but you need to turn on. So I'm going to do an update shadow. Oh, before I do that, actually, you can see that my shadow version is 162, right? I update shadow, and I say on, turn. The device here, let's see if it works. It should turn on. Update shadow, of course, it's a demo. Yeah, it worked, right? So my device updated itself based on what IoT told it to do, which is great. And you can see that, actually, no, wait, so which would have been an increment of 2. I'm not sure why I did that. So what happened is first, we had 2 actions happen. First, the lamp, the board received the shadow update first IoT updated the shadow saying LED is on, desired is on, reported is off, so there's a delta there, right? And then the board turned itself on and went back to the shadow and say, now update the actual status to on, right? So now we're in sync again, right? So you can, so we can see the set state of the shadow here, if I can make it big and smaller. Since I can turn it on, I can, sorry, sometimes it's not up to date totally. So now I'm on, I'm going to say turn yourself off, right? So I've turned myself off. It's thinking long, and it shouldn't be like that. Okay, it was a bit, and you see my version, again, I incremented by 2, right? One was updating the shadow, it's the desired state, and the other one was updating the reported state. So I can see now, desired off, reported off, I'm in sync. So now what, and you can interact directly in the console, but if you have, so this is just a very simple demo with one light. Let's imagine you do like Philips, where you develop a street lighting IoT function for an entire city, where you don't have one light, you have thousands of lights, right? So now centrally you can turn on all your lights, or you can dim all your lights, you can change the color of your lights centrally to all of them, right? Because you will have all your lights subscribed to this shadow delta topic. I'm almost done. So sorry guys for being a bit late. So now this is actually I'm now not on the Edison anymore. I'm on my Mac. Just wanted to show you. I didn't have time to write a nice JavaScript app, mobile app. So I'm just going to show you that I can also communicate with the device through the shadow from using the traditional AWS SDKs. So here I'm just using the CLI. I'm going to use this beautiful function that is very complex, that you can see, that I wrote, that's just basically one line, right? That's just going to say, update my shadow of my light and say, either on or off, right? All the rest is just verifying the syntax. So, so if I do now light as such on, then it updates the shadow on AWS IoT, and then it goes back to this in board saying you should be on, right? And then, of course, I can do off, right? And turn back still off. So one last thing, I promise. Let's say now that, so this is all the trace for my JavaScript. Let's say that, so I'm stopping the Node.js program here to simulate this going offline. So this is broken or rebooting or it's offline. So now let's go back to, let's turn it on, right? So I updated it to on. Of course, it didn't turn on because it's broken. It's not working. So if I go now to the console, oopsie, that's not what I wanted to do. If I go to the console and I update this, I can see that I'm out of sync because my desired state is on, which I instructed, but my reported state is off because the device couldn't update itself, right? Because it's broken. So now if I go back to my device and I reboot it, let's say I'm just restarting the program, but let's say it comes back to life after maintenance or something, it's going to update, register itself, turn itself off first, and then listen to the delta. And once it listens to the delta, it says, oh, I'm not in sync, I'm out of sync, so I'm going to update myself. And now we can see that it's, if I refresh this, it's not refreshing right away, but it should. Okay. That's a demo, right? So I have to have something that doesn't work.
It was already very impressive up to this point.
Thank you. So anyway, yeah, let me just now turn it off. Of course, now I don't know if it's going to work, but we'll see.
So while you're doing that, I was just wondering, how many people are using Amazon services? Just raise of hands. So not that many. And of the people who are raising hands, how many are using EC2? It's like you still have a lot of evangelism to do. That looks
yes.
like, yeah?
So I'm responsible for Central Eastern Europe, which includes Romania. So I'm happy to come back anytime if you guys need us to get more AWS knowledge. So let us know. We're pretty much demand driven, and if there's a need, we will come. So I just show you a little bit how to interact with it. Of course, at the end, it stopped working, because it's a real demo. Now it's your turn, right? So we take care of the backends, but now you need to come up with new ideas and new sensors. And if you want some, you can easily get some toy sensors and play with them. Thank you.